In this video I'm going to show you how to make a game with a basic rising mechanic using both Bolt and C#. So the scene is already basically set up. I've got some sprites. Basically I've got my player set up. He's already got a rigid body on him as well as a circle collider 2D because we're making the scene in 2D. In terms of the scene, we've got some enemies. They're all just using normal circle colliders, and basically their tag is already set to enemies, so I can use that later on. And then the other thing is the coins. They're also using colliders, but they're already set to be triggers, and they are using the tag coin. I think other than that, that's the most of everything in the scene, so we can probably just go ahead and start making the game. So essentially what I want to do is make a game where the little character is flying up in the scene, and then when the user is clicking and holding their mouse, the character will sort of follow the mouse left and right as he flies up through the scene, and the goal is that the player needs to try and fly through all the objects and enemies to try and collect as many coins as possible. So I'll show you how to do that, first in Bolt and then in C#. Okay, so to start, we can make a new flow machine. Flow macro, there we go. And we can probably call this our player controller. And then on our player, we can make a component, flow machine, and then just drag that into that. Cool. And then we can start editing. I'll just dock it down here. Okay, so the first thing we want to do is actually just make sure our player starts in the middle of our scene every time we start the game. So in order to do that, we can just add a start node. Let's wait for it to compile, there we go. Add a start node, and then we essentially just want to set our transform for the player. So we can just say transform set, and 0, 0, 0 is fine because that's where you want our player to start. There we go. Now the player will start at 0, 0, 0 every time we restart the scene. Obviously this depends on what game you want to make, but for this testing this works fine. And so the next thing we want to do is essentially tell the player where it should move left and right, as well as how fast it should move up and down, or at least just up in this case. So we're basically going to be doing everything of this inside the fixed update, because we're going to be using the player's rigid body, and because it's physics driven we want it to happen constantly and not rely on the frame rate. So we'll start off by adding a fixed update, and we essentially want to change the player's rigid body's position, so and make it move. So we'll just add a rigid body 2D dot move position. There we go. And this will allow us to essentially define a X and Y position for where you want to move this rigid body to. If you're doing it in 3D, obviously this will have your Z position as well, but for us it's just X and Y. So now we can start by exposing both the X and Y. So we can just say new vector 2 XY, and now we can basically separate our X and Y and put in our left and right movement in the X and our constant up movement in the Y. To set up some variables along that we're going to be using, we essentially want to get our mouse position, just the X value of our mouse position the whole time, so that when you click the button we know where you need to go. So we can start by creating our mouse position X. We can add that, and essentially normally for mouse movement you want a vector 2, but because we only want the X position of the mouse, we can keep it as a float, and that should be fine. The next thing I want to add is probably a way to sort of control how fast our character slides left and right. because I think we do sort of want a little bit of follow speed instead of just having the character snap to our mouse position. So we can add a let's call it slide speed, and that can also be a float. Maybe just set that to 0.1 now for testing. Okay, so let's start with actually telling it to move. We can add a node and get the transform position. Well, essentially, just to explain what's the best way to move the character now would be, because we don't want it to snap to our mouse position instantly, we sort of want it to go smoothly from where it is now to where it should go. And the easiest way to do that is to use a lib. So we're going to search for mathf.lib, and what this will do is essentially this allows us to put in a current position, put in our destination, and then how fast essentially you want it to reach that destination. So we can plug that into the X along. So for our start position, we just need to get its current transform position. Again, just the X, because we're using the X in this case and not the Y. So we can go transform dot position, and we want get. There we go. And again, we just want the X, so we can go vector2 dot X, and that's what we want to put in the A. Next, we're going to use our mouse position X to tell it where to go to, so that's what we're using in the B. And then for essentially how fast we want them to go to that position, we're going to use our slide speed and put it into that. And this is essentially all we need for the player to actually move left and right to our mouse position. So we can call this move player to mouse position. There we go, and that'll make it follow our mouse position. But at the moment, we're not giving it any value for what our mouse position is. We're just saying it should go to our mouse position, but we're not giving that any value. So the next thing we want to do is essentially just get that mouse X value when we are holding down the button, so we can tell it where to go to. So in order to do that, we want to check for input, and because we're checking for input, we sort of want that to happen every single frame that the game's running, and that way you won't miss a frame where the mouse is being pressed down the first time. So we can add a update, and in that we essentially want to get our mouse button. There's a lot of different ways you can do this. You can say get key down if you want a specific key. You can say get button down if you want to use the input system, for example jump or fire. For this, I'm just going to use get mouse button down because it's the easiest for testing. So depending on what you want to do, you'll probably change this, but for now this is fine. Again, we're leaving that at 0 because that's our left mouse, 0 is left mouse, 1 is right mouse, and 2 is our middle mouse. And now we're going to go ahead and add a branch because we essentially want to check for when our button is actually being pressed. Okay, so if that is true, we essentially want to only then set our mouse position variable. The reason we're undoing it when we get the button down is so that when you're just moving the cursor, let's say you're clicking on something else, or you've got different mechanics in your game, you don't want the player to follow the whole time. We just want them to follow when we're actually clicking. So that's where we're doing this. And essentially we then just want to set this mouse position, so we can hold down Alt and drag that out. There we go, and then when that is true, we want this to essentially change its value. Now to actually get that value, what we want to do is essentially get the X position of the mouse. But because the mouse is obviously on screen and our game is set in a world, we want to use a node called screen to world point to actually translate that screen position to a world position to tell the player where to go to. So we can go and add screen to world point, and we just want position. And now we can just tell it what our main camera is. You can search for camera.main. That's fine. This will essentially just be our only camera in the scene, so that's why it'll work for this. And for our position that we want to translate from the screen to the world point, that's going to be our current mouse position. So you can add mouse position, and we want to input.mouse position get, that's the one. Okay, and then this will give us a technically a vector3 xyz value in world space, but we only care about that x position, so we're going to drag out of that and type vector3.x and get that, because that's the only value that we need, and we can put that into our variable. Now whenever you hold down your mouse button, you'll get that screen position translated to world position, and then set our mouse position x to that value. So I can just name this set mouse position when mouse down. Cool. So now whenever we are holding down our mouse, it'll change that value, and that way we can set our x value for the player. And we can actually go ahead and test that now, and the player should let's just make sure everything is there and assigned. The player should now, when we hold down our left mouse button, it should move left and right. There we go. And as you see, it doesn't snap to the position, it sort of follows to where that position is. Awesome. Okay, so the next thing we want to do is actually get our player to rise up into level. So in order to do that, we want to change this y value. Okay, and how we're going to do that is essentially just apply a constant speed or force. We'll actually just transform the position of the player in the y direction the whole time. And for this, we also want to be able to control the speed of that. You can use this to later on in your game, maybe have it go faster as the game continues or something like that. But for now, we're just going to add this, call it rising speed. And this should also be a float. Okay. So what we want to do is we basically want to get our current position of the player, and then add whatever our rising speed value is to our current transform position of the player, and that way it'll every frame constantly just send the player up, well every fixed update frame. So the first thing we want to do is we want to get our transform position, get, and in this case here we're using the x value. In this case we just want the y value, so vector3.y, and we basically want to add this with something else. So let's just add, there we go. And we're going to be using our rising speed as a multiplier for our constant force in the y. So we're going to multiply our constant, there you go, our rising speed, and we want to multiply it essentially with our fixed time.delta time. There we go. And then that's what we want our y value to be. So essentially this should send the player up at a constant speed into the world, in the y direction of the world. So this is going to essentially move the player up. There you go. Okay, so now if we test this, our player should technically just fly up into the sky, and we should still be able to control it left and right. We actually need to give our variable a value, so we can make this something like 4. Let's test that. There we go, and now our character flies up into the world. But now you see the next thing is our character is flying, it's following our mouse position in the X, but obviously our camera isn't following, so that's the next thing we want to address. So in order to do that, we'll create a new flow machine and call it our camera follow. And essentially go to our main camera and then add a flow machine component and then drag our camera follow into that. Okay. So essentially we want our camera to follow our Y position of our player. We don't want the camera to move left and right when our player moves left and right as well, because that's going to make the whole scene look a bit weird. We just want our camera to follow the player in its Y direction. So let's go to our camera and edit that graph. Okay. So essentially we want our camera to constantly do that, so we're going to put this in the update, and we're going to be setting its transform position every frame. So there we go, and now we just need to tell it essentially what vector 3 we want it to be set to. So now in order to tell it what to follow, we're going to be adding a scene variable instead of an object variable, because we are going to be using our player for our scene variable, and we can call this our player prefab, or just player. Anything is actually fine. I can call it our player object, and this is going to be a game object. And then the next thing we want to do is actually just get our position of our player, and then tell our camera that that is what we want its Y position to be. So we can add our player, say transform.position get, there we go. And we essentially just want our Y position for this, so we can go vec3.y, and then we want to basically, if you think about how our scene is laid out, if we just set it to our player's position, the player will always be in the center of the screen, and considering that the camera is always going to be moving up, we sort of want to add a little bit of headroom in here to just give the player some more time to react to what's actually happening. So we sort of want to add a offset to our camera. So I think let's create a object variable for our camera offset. It's going to be a float. Maybe make it something like 3 for now. And we're basically going to just be adding that to the camera's current position. So this way you can control how much you want the camera to be offset from the player's position. Okay, we're just going to basically be adding that, and we basically want a new vector 3, and this is going to be its Y position. For the X and the Z values, we sort of, I think the best way would be to have whoever's making the game set up the camera in the position that they would want in terms of how far they want it from the player, and the offset, so that essentially they can place the camera, and then wherever that camera starts, that's what the start position or the constant X or Z position for the camera is going to be. So to do that, we're going to add a start, and we actually want to create basically a vector 3 variable where we can actually just set our transform. So what we want to do is we want to go to our object. Object variable should be fine. Go back. There we go. We can call this our start position, and we want this to be a vector 3. Well, actually, we can probably just yeah, that should be fine. Let's make a vector 3. That should be fine. We actually want to hold down Alt when we drag this out, so we can set it. I'm going to delete that, and we want our start position for this to be just our transform for this camera. So we can add transform dot position, and we just want to get it. Essentially, this will just set this start position variable to whatever our camera's position is when we actually start the scene. Cool. And now we can basically use that start position variable and set our X and our Y. So we can basically just let this make a bit more sense. We can drag this out and get our vec3.x and our vec3.z, because we only want the X and the Z value because we are setting our own Y position, and we want to drag that into our X and Z. And now what this will do is it'll follow the player's position and add this offset that we added, and then it'll set up its X and Z values with our defined start position when you actually start the scene. So this basically just follows our plan. Awesome. Okay, and now before we can test it, we actually just need to assign our player object variable. So again, that's going to be a game object, and we want this to be our player. So now the camera should follow our player as it moves again, depending on that offset position. So now we can test it, and there we go. The player flies up, the camera follows it, the player can move left and right, and the camera stays in the middle, and there we go. That works fine. Okay, so then the next thing we want to do is essentially, if you think about what's happening in the scene, we've got our character flying up, and it can fly up, and basically there's nothing that's going to stop it, or anything that's going to happen. So we want to add events for when the player collides with an enemy, and when the player actually picks up a coin. So I'm going to start with just when the player is actually colliding with an enemy. So on our player, I'm going to go and essentially search for like I said earlier, our enemies are using normal colliders, and they are using predefined tags that are set up. So what we can do with that is basically make it a lot easier for us to find that we are actually hitting the enemy. So I'm going to search for a on collision, and I want on collision into 2D because we're making a 2D game. And essentially what I want to do is when we collide with something, and in our setup it's always either going to be enemy or coin. So I want to search for GameObject.compare tag, and we want to compare that, and the tag that we are basically comparing is it an object with the tag enemy, and then add a branch to say if it is the enemy, what must it do. So in our case, for testing, we just want the scene to restart whenever we hit an enemy. Obviously, depending on your game, you maybe want to set up actually the player losing some score or losing some lives or something like that. For this, we just want the scene to restart. So I'm going to go to our scene manager dot load scene, and we just want our scene build index. There we go. And essentially out of this, get our, there we go, and get our active scene. And then what this will do is, if we collide with something and it sees that the tag is enemy, it will reload our current scene. And this is just essentially, restart when colliding with an enemy. Cool. Okay, so now we can actually test that and see if it works. Wait for it to compile. There we go. So now I'm flying up, and if I hit something with that tag, it restarts the game. You'll see for now we can't do anything with the coin, but the moment I hit an enemy, it restarts our scene. Awesome. Okay, so now that works, essentially we want to do a similar thing for the coin, but in this case we want the player to actually pick up the coin, so we want the coin to sort of disappear and then add to a score value for the game. So because our coin isn't, we're not going to collide with the coin because it's set to trigger, we want to check for when we're actually entering the trigger. So we're going to search for a on trigger enter, and we want 2D, and then again we're going to do the same thing where we compare the tag, and we're going to compare the tag of the object that we collided with, and we want to say if that tag is coin, do the following. So again, add a branch, and if it's true, for now I think oh yeah, so let me put it like this. So how we're going to set it up is we also want our score obviously to update on the screen. So an easy way to do this is if that is happening in a separate bolt script, we want to send a custom trigger or custom event to make that score update. So essentially in this we just want to fire off that custom event and destroy the game object. So what we're going to do is send off a custom trigger custom event, and we're going to call it add score, and the object that is going to be on is going to be our UI manager that we'll create after this. So we'll create a new object variable and call it our UI manager, and it's going to be a game object, and essentially it's going to then search for this custom event on our UI manager whenever we collide with something with the coin tag. And then just to make it look like the player is actually picking up that coin, we want to destroy the coin. So we can go game object dot destroy, and we just want this object that we are triggering. So we want our collider 2D dot game object, and again we just want to make sure we get the 2D one. There we go, and that's the object that we want to destroy. And this is basically going to well, let's just pick up our coin and add score. And now before we test it, we can actually create this custom event to actually do that. So I'm just going to use my canvas for our UI manager. So on my player game object, I'm going to go to my variables and just say that our UI manager is our canvas. And then on the canvas I'm going to create a new flow machine and call this our UI manager, and add a flow machine component, and then basically start opening that. Okay, so what we want to do on this is essentially just fire off the custom event and have our score actually change and it actually display on screen. So for this we want our score variable actually to be a scene variable, so that it can be accessed with a lot of different stuff because it's sort of your game score. So we can just add a score total, and that's going to be an int because it's going to be in incrementing in essentially we're not going to use any commas for the score, it's just going to be full numbers. So for this we want to create our custom event and we called it add score, and remember this needs to match with wherever we are firing off this custom event. It is also case sensitive, and what we first want to do is actually add to our score. So let's say our score is 0, we can pick up a coin, we want to add 1 to whatever our current score is. So I'm going to hold down Alt and drag out our score total, and essentially just want to set this value to whatever it is currently plus 1. So we can drag out our score total normally, add, and we want an int literal, and we just want it to change by 1, and that's what's going to be our new score. So every time this changes, it's going to look at whatever it was and then just add 1. The next thing we want to do is actually also change our on-screen score text. So how we're going to do that is I'm going to add a new variable in our objects called our score text, and that's going to be of type text because it's going to be a text component on our UI. And I'm going to essentially search for a text.set, and the text that it should set is our variable, and then the value that it should be, we essentially want it to display not just a number but sort of in a formatting where it says coins semicolon and then whatever our current score is. So to do that, I'm just going to add a string.literal, there we go, and we basically wanted to say coins with semicolon and a space, and we want to add whatever our current score is to this. So because our score is obviously an int, we want to convert it to a string before we can actually use it in our text. So we can just say to string, and there we go, int to string, and then we want to combine it with this. So we can say this, we want to add whatever our current score is, and that's what we want to set our text to. There we go. And this is our custom event to update our score. There we go. Okay, so now whenever we pick up a coin, we should see our score total increase by 1. The coin should disappear and our UI should update. So let's test that. Before we do that, I think we need to also just we need to assign on our canvas, we need to actually assign our score text variable. So just make sure that's text, and we want to drag in this game object because that's the one with the text component. So then when we hit play, you can see that it flies up and it collides with the coin, picks it up, the coin disappears, and our actual score does increase. There we go. So I think that about covers everything for the basic rising mechanic in Bolt. So now we basically want to do the exact same thing, but with C#. So okay, there we go. So just save this, and then what we want to do is open up the empty scene again. Okay, so now we want to basically redo that but with code. So again, we're going to be using the same approach where we start off with the player following our mouse movement left and right. We then want it to actually rise up constantly. We want our camera to follow that, and we want the player to be able to collide with enemies and coins. So let's start with our actual player controller. So I'm going to go to my scripts and create a C# script for my player controller. Okay, and I'm going to open that up and remove all of that. Okay, and again, I want to set up my variables similar to what I did with the Bolt version of this. I'm going to start off by actually making a private float for our mouse X position. So yeah, to start off, we're going to basically first try and actually just get our player to follow left and right with our mouse position. So create a private float for our mouse position, and it's basically our X position. And then we want to basically declare our rigid body, so we can actually use that to actually transform it and reference it. So we're going to create a private rigid body, and again rigid body 2D in this case, and we can just call that our rigid body 2D. And then we want again to create our slide speed, which is basically going to be what is controlling how fast our character is following our mouse. So we can just create a private float again for our slide speed, but we do want to be able to actually manipulate this in the editor, so we can just make it serializable. Okay, and then we want to start again by getting our player to start at the 000 position, same so that when the scene actually starts, we know it's in the correct position. So okay, so we basically want to set our player position at start, but we first want to tell it actually what our rigid body is. So we're going to create an awake function and tell it that the rigid body 2D is get component, and we want to get our rigid body 2D component. There you go. Okay, and then essentially in our start, we want to say that our rigid body's transform.position is basically, we want to zero that out. So we can, there's different ways to do this, but we can just say vector 3.0, and that way it'll set the position to 000. Okay, so next we want to basically get our mouse position for when we're actually holding down the mouse. So inside our update function, we're going to check for input. So I'm creating an if statement, and here we want to check for if our left mouse button is being held down. So again, we'll go input well, in this case get mouse button, and we want to get the left mouse button, and then if that is the case, we want to set our mouse position value to be wherever our mouse is on the screen, but then what that value is in world space. And in order to do that, we're going to be using the screen to world point. So essentially what we want to do is go to our camera.main to get our main camera's component, and then just use screen to world point, yes, that one, and we now need to tell it what it's actually looking for, and for this we're looking for our input dot mouse position, but in this case that's going to return a vector 3, and we just want that x value to make it follow left and right, so we're just going to go dot x, and that'll set our mouse position. And then essentially whenever we're holding down that mouse, it's getting that value and setting it to that. So next, to actually use that, I'm going to create a fixed update, and inside this we want to check for essentially setting our position for our player. So we're going to use that rigid body dot transform dot position, and we're going to tell it that it is basically going to lerp between whatever its current position is, and then go to wherever the mouse position is, and then again based on our slide speed. So to do that, for the first part of the vector 2, we want essentially to use that mathf.lerp function, and we want it to load from our current position in the X, so our rigid body to the dot transform dot position dot X, and we want it to move to our mouse position value, and we want it to essentially the speed it needs to follow is our slide speed. There we go. And then we just need that's our X value, and of course we've got to tell it what it needs to do with its Y value, and in this case we just want it to stay wherever our current Y value is as it moves up in the world. So we can just say rigid body dot transform dot position dot Y. Cool. And now if we test this, our character should follow our mouse position in the world. So let's actually go to our player and assign our code onto the player and just set our slide speed to be 0.1, and now we can test that. There we go, and the player follows our mouse position. Okay, so next we wanted to actually move the player up. So what we're going to do is basically get our current position in the Y, and then just add our or we can make a variable for our rising speed, and then just use that to actually constantly make the player move up. So we're going to duplicate this and create a variable for our rising speed. Okay, there we go. And then this is also going to happen in the fixed update. So basically we want to multiply that with our fixed delta time and then add that to its Y position. So we can probably combine that into this. So that's getting our current position. So we basically want it to be there, but we want to add our other values. So we can say that plus our essentially our rising speed times our fixed delta time. For that we actually need to go time dot fixed delta time. There you go. Okay, and then just put this in brackets, and then there we go. So now according to our rising speed, it'll move up in the world, and we probably just want to set that rising speed value to maybe something like 4, and now we can test that. There we go, and our player moves up in the world. We hold down the mouse button, we can make him fly left and right, and that works. Again, now we want the camera to actually follow our player in the world, so let's create a camera follow script. Camera follow, and with this let's open that up, and we can delete all of that. Again, we want to first start off by telling it what it should follow, so we can make a or we can make it, yeah, for this we can just use public game object and call this our player object. And then again, we want it to be offset a little bit, so we can add a value for that. So we can create a private float and call it our camera offset. And this we still want to be able to edit that in the actual editor, so we can just make it serializable again. So add that, and again, we also want the camera to start off wherever we actually set it up. So we can use a private vector3 and call it our camera start position. There we go. Okay, so now at the start, or in awake actually, we want to set our camera start position. So we can say our camera start position is our current transform dot position. And that's all we need for that. To actually get it to follow our player with that offset, we want to create a update and say transform dot position equals new vector 3, and basically again we're going to tell it to stay at the X position where it was at the start, move in the Y position to where the player is with that offset, and then stay in the Z position to wherever we also set up at the start. So for this we want our start position dot X. For the Y we want our player's position, so we want our player object dot transform dot position, but again just the Y position, and to that we want to add our camera offset. There we go. And then for the Z we again just want our start position dot Z. Cool. There we go. And now we can go back into Unity, wait for it to compile, and then add that onto our main camera. And then we still need to assign our player, so we drag in our player, and for this I think our offset was around let's check the values, I think around 3. Let's test that. So again, you can mess around with this value depending on what you want yours to be. There we go. Now the camera is moving up along with the player. You can hold down the left mouse button and actually make him move around. Now the next thing we want to do is actually do something when the player collides with the enemies as well as with the coin. So we can go back into our player controller code, and what we want to do is essentially again check for our on collision enter for the enemies and our trigger enter for the coin. So let's start with the enemies. Basically want our on collision into 2D, on collision into 2D, there we go. And basically want to start by comparing the tag to see if it is the enemy. So we can go if other dot game object dot tag. Well, actually we can just use an easy way to do this is to just use dot compare tag. There we go, and we want to compare it and see whether it is enemy. Okay, and then again when it collides with the enemy, we wanted to restart the scene. In order to do that, we first need to add up top our using Unity engine dot our scene management, and again later on, because we're going to be controlling some UI, we probably want to add that in as well. Yeah, we can probably add it in here, so I think let's add it now. We can go using Unity engine .ui. This will allow us to basically edit that text component to update the score later on. Okay, so on collision we basically wanted to restart the scene, so we can go scene manager dot load scene, and which scene do we want it to load? We can say scene manager dot get active scene, and want to add dot build index to get whatever our current scene is. That way when you collide now with the enemy, it'll restart the scene. Okay, there we go. So now we can go ahead and test that and see if it does restart the game. And there we go, it restarts the level. Awesome. The next thing we want to do is actually collect that coin and change our score value. So in order to do that, we can probably just do it within our player code. We don't need to create you can actually create a separate UI manager to set that up, but for this I'm just going to do it all in the player's code. So for this I'm going to add a on trigger enter, and we want on trigger enter 2D, and we want to say if other dot compare tag. If you notice, in this case we don't need to say other dot game object dot compare tag. We can just say other dot compare tag, because it's just we're using a trigger in this case instead of checking for collision and then based on what that collision object is. So we can just say other dot compare tag, and in this case we want to say when it's with coin, or when it triggers coin. And what we can do is we can add a variable up top for our current score. So let's create a public int and call it our current score. And we also want to be able to actually change our text on screen, so we can add a variable for that as well. So we can say public text and make that our score text. There we go. And now essentially whenever we trigger something with the tag coin, we can tell it to essentially +1 to our current score. And an easy way to do that, instead of saying our current score is whatever the score was +1, instead of doing that we can just say current score ++, and that will automatically increment whatever the current score was by 1. Then we want to actually destroy that coin that we collided with, so we can say destroy, and what do we want to destroy? We want to basically destroy whatever that object was that we triggered, so we can say other dot game object. Cool. And then last thing we want to do is we want to actually update our score on the screen. So we can use our score text, and obviously that's an object, so we want to say, or component, we want to say the text on that component should be, so we say score text.text. And we can say, again, we want the same formatting where we have our score, semicolon, and then whatever the score is. So we can say score plus whatever our current score was. And again, remember this is an int, so we want to convert that to a string. So we can just say dot to string. And there we go. So now if we go back to our code, or to Unity at least, we can go to our player, and now we just need to assign whatever that text is. So we can open our canvas and say that our coin text is that. And now if I test it, if I pick up a coin, it increments the score by 1, and it actually updates the score on the screen as well. Awesome stuff. Okay, so yeah, that was how to make a basic Rising game with Bolt and C#. And in the next video we're going to cover how to do a falling game, again using Bolt and C#.